Hey guys, so I'm just gonna try out a little bit of this delta math. So here is trying to go from standard to vertex form on a time trial, all right? So if I'm looking at x squared plus 14x plus 42, all right? So I am gonna say x squared plus 14x. I'm gonna move my 42 over here, and I'm gonna try to complete the square for 14x. So that's 14 over 2 quantity squared, which is 7 squared, which gives me 49, which means I'll be adding 49 to this equation and subtracting 49. All right, I'm going to factor this trinomial, and it factors into x plus 7 quantity squared. 42 take away 49 is going to give me minus 7. So I look for that choice, x plus 7 quantity squared minus 7. All right, and it looks like it's this guy. All right, change back to this tool, and boom, I got it. Okay, so that's how you do that problem. Okay, and let's stop that right there. All right, I'm gonna change that to see if you can knock out 2 of them in 100 seconds. All right, and let's see. The thing about patterns that are quadratic, linear, or exponential. All right, so you notice between consecutive x values, what is the pattern? Right here from 4 to 8, we went up 4, or you could say we doubled. From 8 to 16, doubled. 16 to 32, doubled. 32 to 64, you doubled. That is an indicator of an exponential function, all right? Anytime you're saying something like times 2 in between, right, or you have what you call a common ratio in between terms, you're exponential, all right? Looking at another, that one's exponential as well because you could multiply by 1/2 each time or divide by 2. All right. Here you see consecutive x values, and I'm going from -6 to -7 to -8, -9, -10. This one's going to be linear, all right, because I'm going down by the same amount that has a constant rate of change. All right, and let's see if we can find a quadratic one. All right, so that one is doubling because that's exponential. This one looks pretty quadratic, does it? Yep. Okay. So one thing you'll notice about quadratic, well, in the first place, you have perfect squares right here. Okay, and let me erase this. But one thing you're going to want to notice between consecutive values, how far away are 9 and 16? Well, they're 7 units apart. 16 and 25 are 9 units apart. 25 and 36 are 11 units apart. 36 and 49 are 13 units apart. Do you notice a pattern here? 7, 9, 11, 13. They all have a common second difference. That common second difference is 2. That is an indicator that this guy is quadratic. So quadratic functions have a common second difference. All right, and selecting forms for quadratic features, best thing that I can tell you is vertex form. Best use of it is, well, to find a vertex. All right, don't forget that that's located at HK. All right, your standard form, what's that good for? All right, standard form is best when you're wanting to locate your y-intercept. All right, because it's just going to be your c value. And last, we've got our factored form. All right, so factored form is best for finding the zeros or x-intercepts, because, for example, if you have a function x minus 3 times x plus 4, you can locate zeros at x equals 3 and zeros and a 0 at x equals -4. That's for that type of quadratic. So that is a summary of your 3 forms and the different type of problems that you could have with it.